Good evening. I hope everyone had a great day at school today. Hope you learned a lot of things today. I had a great day. Can't wait for tomorrow. Here we go. Alright, so what I want to do first, guys, is due to your homework problems that deal with graphing, cosecant, and secant, to make sure that you're good at that. And then we're going back into what we're starting to talk about today. Do not stress right now. The inverse trig that we started in the class will come to you, especially after watching this video and tomorrow's lesson as well. But what's going to happen tomorrow is this, guys. I'm not going to be here when you get in here. I have your complete instructions on the board, like I normally, in the agenda, written out, like what you're going to do first thing. First thing you do is complete 4 problems on your first semester exam study guide. The second thing, you're going to complete a checkpoint on tangent and cotangent functions. You're going to graph one tangent and one cotangent. After that, I'm going to have your homework worked out, and I want you to check your homework, and then go into completing page 14, which is what this video is dealing with, inverse trig. So that's your schedule tomorrow, and I'm going to be back in here halfway through the class, and we're going to continue with page 14. Alright, so let's look at number 9 here. My amp is 2. My period. I can rewrite this as y equals 2 cosecant 1/2 theta. So my period formula is 2 pi over b, which in this case would be 2 pi over 1/2, which is equal to 4 pi. Alright, I'm going to graph this. I'm going to take this, divide by 4. It means I'm going up by intervals of pi. Alright. Now cosecant is the reciprocal of sine. Is the reciprocal of sine. So you start at the origin. With your dots. Now this is where it becomes different. Wherever it crosses the x-axis will be an asymptote. Like here, it's sitting on the x-axis. So I'm going to have an asymptote going through here, 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 and here. Then we're going to draw our curves. Remember, it cannot go past the x-axis and do not go beyond these two asymptotes. So you're going to draw it up way like this. And that is my graph for y equals 2 cosecant theta over 2. Alright, let's look at number 10. I have y equals secant theta over 3. I can rewrite that as y equals secant 1/3 theta. My amp is 1. My period is 2 pi over b. In this case, it would be 2 pi divided by 1/3, which is 6 pi. Take this, divided by 4, that's going to be 3/2. I'm going to go about 3/2. 3 pi over 2, 6 pi over 2. 6 pi over 2 is 3 pi. 9 pi over 2. Then 12 pi over 2 is 6 pi. 15 pi over, okay, this is 9 pi over 2. That is 12 pi over 2. 15 pi over 2. Then 9 pi, because it's 18 pi over 2. Then 21 pi over 2. And then 24 pi over 2, which is 12 pi. What about 3 pi over 2? 3 pi over 2, 6 pi over 2, 9 pi over 2, 12 pi over 2, 15 pi over 2, 18 pi over 2, 21 pi over 2, 24 pi over 2, which is 12 pi. My amp is 1. Okay, secant is the reciprocal of cosine. Remember, you start the amp. Wherever, this is where it's different, wherever it's sitting on the x-axis, it will become an asymptote. Then you go back and draw your curves. And that is your graph of y equals secant 1/3 theta. You can check 11 and 12 tomorrow in class when I run this off for you. Okay? So now let's talk about what we're here for today. A little preview. Clear any misconceptions right now. We're still talking about today, guys, about inverse trig functions. Alright, we talked about sine, cosine, tangent. The inverse of sine is denoted as sine with that little -1, or it can be called arc sine x. Either way, you can see it. If you see it this notation or this notation, that means the inverse. Cosine, tangent, now these are the inverse of these three traditional trig functions. I know you're thinking right now, well, Mr. Esther, I thought the inverse of sine is cosecant. Those are reciprocal functions. These are the inverse. I know we use the word inverse loosely when we say the inverse of sine is cosecant, the inverse of cosine is secant, but that is really the reciprocal of the three. Like the reciprocal of sine is cosecant. The reciprocal of cosine is secant. The reciprocal of tangent is cotangent. That means they're flipped. But the inverse of sine is arc sine. Inverse of cosine is arc cosine. Inverse of tan is arc tan. So that is the more proper definition. These are the inverse. So these do not mean, that does not mean cosecant, that does not mean secant, and that does not mean cotangent. Like I said, those three are known as the reciprocals of these. These are the inverse trig functions of these. And you say, well, are there inverses of secant, cosecant, cotangent? No, you only got to know these three. These are the three true inverse of these three. Alright, so today we started talking about, you got to know where these inverse trig exist. In sign, it exists from negative pi over 2 to pi over 2. So, if we have so that means that your answers, if you have arc sine, your answers are coming from, because this is negative pi over 2, and this is pi over 2, so it's coming out of these quadrants right over here. Quadrant 1 and quadrant 4. Quadrant 1 and quadrant 4. Cosine, the inverse of cosine, the arc cosine, is this from 0 to pi. That means from here to here is 0 to pi. That means your answers exist for arc cosine in quadrants 1 and 2. Notice brackets are around these two. That means it can include these two can be an answer. These two can be an answer. So that's 0 pi. The tangent is from negative pi over 2 to pi over 2. Notice parentheses around these. These cannot be answers, but everything in between them. So if we drew this, that means your answer will be coming out of quadrant 1 and 4. And we talked about why that happened today, because in traditional sine and cosine, your domain is all row numbers, and your range is negative 1 to 1. Well, that flip-flops in the inverse, and therefore the domain is negative 1, 1. It restricts your range. So that's why these have restrictions on them. Now, I am looking at your note taker right now. This is page 14. You want to fill in this important information. It's very important. The inverse sine function is referred to as the arc sine function. There's the notation. We talked about the range is restricted. We just talked about that. The inverse cosine function is referred to the arc cosine function. There's that information, and so forth. The inverse tangent is referred to as arc tangent, and here's the notation. You're not going to have to graph these, but this is how the graphs look. You know how the sine traditionally looks like that. Well, the inverse, when your domain and range flip-flop, there's what you get. And so forth for arc cosine and tangent. Those are the graphs. Okay? Alright, so I'm going to pull some examples on page 14 just to see you get used to this. So I'm on number 1. Okay, I'm going to show a lot of steps here, guys, so this can click with you. We're looking for the inverse, the arc sine of 1/2. Okay, so remember, like I told you today, you're working backwards. You're used to, for example, let me just make some up, sine of 5 pi over 6. This is what you're used to on your Trig quiz. You know, it's quadrant 2, order pair is this, so the sine will be 1/2. Well, guys, what I'm doing now is giving you this, and you've got to give me this as your answer. You're working backwards. That is the whole point of here. So I sit here, and I got the arc sine of 1/2. Okay, so I have to think, which ordered pair, now sine deals with your y, has a y value 1/2. That is pi over 6. Okay? Now, looking up here, the answer can either come out of quadrant 1 and 4. This is your y value. It is positive. So, is the y positive in quadrant 1 or quadrant 4? I hope you're saying 1 because it is 1. So I have to think, which pi over 6 is in quadrant 1? Well, let's think about this. You have 1 pi over 6. Of course, that's in quadrant 1. 2 pi over 6 reduces. 3 pi over 6 is pi over 2. 4 pi over 6 is way over here. So I only have one member of the pi over 6 family in quadrant 1. Therefore, my answer is that pi over 6 is my answer. Number 2. arc sine of negative square root of 2 over 2. I think, okay, which ordered pair has a y value that looks very similar? That's pi over 4. Pi over 4. Now, the sign, this means my y value is negative. So I think, okay, is it in quadrant 1 or quadrant 4? That's quadrant 4. Okay, so I'm thinking, okay, what pi over 4 is in quadrant 4? I got 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4 is in quadrant 4. So 7 pi over 4 is what I'm dealing with. But that's not your answer, guys. But that is you're right to think is 7 pi over 4. But I want you to look back at this interval right here. The interval says from negative 1/2 to 1/2. The numbers fall in between this. Well, if you look at 7 pi over 4, how many times does 4 go into 7? 1 time, 1 3/4. Well, 1 3/4 do not fall in this interval. So you have to think, is there another way that I can write this that means this same point? Well, guys, let's think about this. If in quadrant 1, this is pi over 4 this way. If I went pi over 4, I'm here. What if I went negative pi over 4? Negative pi over 4 will be down here. Is it negative pi over 4 the same point as 7 pi over 4? Is it negative pi over 4 the same as 7 pi over 4? So, and negative pi over 4 falls between negative 1/2 and 1/2. So you cannot write this, but instead you can write it as negative pi over 4. And that is your answer, and that is the same point as that, because it's down here. Okay, if you need to stop right now and review those two examples, please do. Okay, I'm going to look at number 3. The inverse of the arc sine of square root of 3 over 2. Okay, so my y value is square root of 3 over 2. I have to think, what order pair am I dealing with? Pi over 3. Okay? I'm going to zoom out for just a moment here. Alright, now the y value is positive, so I'm still looking at the sign. It's going to come out quadrant 1 or quadrant 4. Since my y value is positive, it's going to come out of quadrant 1. Well, I got to think, what pi over 3 value is in quadrant 1? Hope that didn't take you long to think. Of course, it's just, you have pi over 3. 2 pi over 3 is over here, so your answer is pi over 3. Number 4, arc sine of negative 1. Okay, your y value is negative 1. Well, guys, it's going to be between 1 and 4. You know up here is 0, 1, and this is 0, negative 1. I know it's dealing with this point right here, which is 3 pi over 2. But we can't use 3 pi over 2. We got to find another way to write 3 pi over 2. Because 3 pi over 2 is 1 and 1/2. Does 1 and 1/2 fall between this interval? No. But could I use, if from here to here is pi over 2, could I not use negative pi over 2? That means the same thing as 3 pi over 2. So that would be my answer. Alright, number 5. Arc sine of 3. Guys, do we have anything on the unit circle that gives us a y value of 3? No. Does not exist. Okay? Number 6. Arc cosine, or the inverse cosine, you can say it either way, but make sure you say it either arc cosine or the inverse cosine function, negative square root of 3 over 2. Okay, so we want to know what gives me that. Well, cosine is your x. This is the x value. So I'm going to think, okay, which one had an x value of that? That's pi over 6. Pi over 6. Now, remember, sine was this interval, cosine changes, is 0 to pi. I'm going to quadrant 1 and quadrant 2. I got an x value that is negative. So that means I'm in quadrant 2. So I have to think, what pi over 6 family is in quadrant 2? Let's go. Pi over 6 is in quadrant 1. 2 pi over 6 reduces. 3 pi over 6 is here. 4 pi over 6 reduces. 5 pi over 6. 6 pi over 6 reduces. So, which one is it? 5 pi over 6. You said, Miss Chester, is that one okay? Well, let's think. This interval is from 0 to 1 pi. Can 6 go into 5 at least once? No, that falls between 0 and 1. So this is your answer. This is okay for that interval. Number 7. The inverse of cosine or arc cosine of negative square root of 2 over 2. This will be my last one. Okay, this is familiar with the pi over 4. Cosine, the x is negative. That means you won't come out of quadrant 2. Quadrant 2. So you have to think, what pi over 4 family is in quadrant 2? 1 pi over 4 is in quadrant 1. 2 pi over 4 reduces. 3 pi over 4. And that is your answer. Alright guys, tomorrow we're going to finish this page 14 and we're going to go over that. So that's what we're going to work on today. Thank you for watching the video and I will see you tomorrow.